Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on WAN Layer 2 technologies. Let's start our part 2.
Now we have two types of authentication. So we have a PEP authentication and the other authentication is CHAP. Now these two authentication are slightly different. So as you can see here on the PEP authentication, we will have a request and an acknowledgement. That's all. Alright. So assuming that you are going to challenge based on the PEP authentication, the authenticated party will use this packet to send the username and password. Okay, and the data field contains the plain text of the username and the password. Whereas the authenticating party is going to accept it based on the password. If it's correct, it's going to send an acknowledgement. If it's wrong, it's going to send a negative acknowledgement. Alright, so let me show you the trace on this authenticated request and authenticated acknowledgement. So here I have my Wireshark. As you can see from here, these are all the LCP and this is a PPP authentication request. So if I expand the PEP password authentication, this is the authenticating request. I'm requesting for authentication. So as you can see that this is my peer and this is my password. And if let's say the authentication is accepted, then the other side of the router is going to send a acknowledgement saying that, hey, your username and password is accepted. So we have the authenticate acknowledgement. So here we have the PEP packet. All right, and let's look into the process over here. Now on R1 I have the authenticating party and on R2 I have the authenticated party. So on the authenticated party I'm going to send a request. So R2 send the username and password in plain text, whereas the authenticating party is going to accept it or reject it based on the negative acknowledgement. Right, so this is the PEP. Next we are going to look into the CHAP. Now let's look into the CHAP authentication. Now CHAP authentication are slightly different compared to PEP. As you can see that inside the packet type for CHAP we have 4 types. Now first will be on the challenge. Now challenge is sent by authenticating party. Alright, so it will send a challenge packet to the authenticator to initiate an authenticating. Now once the authenticated party receive it, it's going to send back an MD5 and this is as a response from the authenticating. So the authenticated party will send and respond. Alright, it will using the MD5, the encryption algorithm. Now the end result, it will be either success or failure. So success, as its name suggests, that the authentication is success, else it failed. Right, so as you can see from here, this is the authenticating party, all right, using the username and password as an hello. So the authenticating party send a challenge. All right, the authenticated party will be sending an MD5 as compared to earlier one. If let's say we go back into the PEP, as you can see that they send the username in the plain text. So the CHAP is more secure in this sense. So once you send back the MD5, then the authenticating party is going to send another packet, is either success or failure. So again, let's have a look into our trace. So here you can see that I have a CHAP, that is our challenge. Okay, so this is a challenge by the authenticating party. So if I just expand the PPP, you can see that this is a challenge, handshake authentication protocol. All right, and this is the content. As you can see that the content here is contain the challenge value. Now once the authenticated party receive it, is going to respond. As you can see that this is my username and the password is actually MD5 is being hashed. And assuming that now the authenticating party do receive it, then you will able to see the result is either success or is a failure. Alright, so in this case, clearly indicate that this is a success. So here we have our trace and the working principle on the CHAP authentication. Now once the PPP LCP completed, alright, LCP completed, the next stage will be on the NCP. Alright, so this is mainly on the layer 2 and this is mainly on the layer 3. So here we have two types of configuring of the IP address. It's either static or dynamic. So here we have this static IP negotiation. Now assuming that R1 here is using 12.1.1.1/24 and R2 is using 12.1.1.2/24. Now R1 is sending the configure request. This is under the IPCP. So assuming that we are using this IP. So I'm going to send this information across the link saying that, hey, I'm going to configure 12.1.1.1. So it's being acknowledged by R2. Now R2 in return also have to send a request telling R1 that R2 is using 12.1.1.2 and being acknowledged by R1. So let's have a trace, have a look into my Wireshark trace. So as you can see here, I have the IPCP. Alright, so under the IPCP, if I expand it, so assuming that you can see that the LCP is already completed. So once the LCP completed, this is where the NCP take place. And you can see from here on the IPCP, I have an option. I'm actually requesting IP address of 1112. And you can see that it's being acknowledged. Alright, this is acknowledged. This is a request. This is on the other router. This is actually requesting for 1111. And you can see that it's being acknowledged for the 1.1.1.1. Alright, so this is the complete of the static IP negotiation using IPCP. Now the NCP protocol negotiation for static and dynamic are slightly different. So let's look into the dynamic IP address negotiation using ICP. Now assuming that R1 here have no IP and request for allocation. So R2 do have IP. The IP address that is statically is 12.1.1.2. And in R2 we do have configured the 12.1.1.1 as the IP address that's assigned to R1. Now the first phrase here is R1 is going to configure a request, sending a configure request to R2 and requesting for 000. Now upon receive the 000, R2 will send a configure nag saying that 000 is not acceptable. So I'm allocating 12.1.1.1 to you. Now R1 upon receive it is going to change the parameters and requesting for 12.1.1.1, and R2 is confirmed by sending a configure acknowledgement. At the same time, R2 will also send a request to confirm that I'm using 12.1.1.2 and finally being acknowledged by R1. So let me show you the Wireshark trace here that I already done. Now you can see that I have R1 and R2. This is where we have R1 just now requesting an IP address of 000. So when R2 receive it, it's going to send a negative acknowledgement. Alright, so saying that, hey, I'm going to send you a 1.1.1.1 because that 00 that you are asking is not valid. So that is where I'm sending you a configure nag. Then R1 is going to change its parameters and requesting 1.1 and finally being accepted by R2. Now at the same time, you notice that R2 also asking for 1.1.1.2 and being acknowledged by R1. So here we have all these 1, 2, 3, 4, 5, and 6 packets that complete the dynamic IP addressing using IPCP. Now let's look into the MP principle. The MP here stands for multi-link PPP. In essence, what it means here is assuming that I have R1 and R2, and if let's say both the link here is insufficient bandwidth, I'm going to do a multi-link PPP. So this is to increase the available bandwidth. Alright, so that is the main purpose of using MP PPP, to improve the bandwidth. Now the concept of the MP principle here, they are still using the LCP and NCP phrase. No difference over here. So in the first phrase, the LCP negotiation is performed to check whether the remote interface does work in MP mode or not. Else then they fall back into the individual single PPP. And once that is already done, then they will move on to the next phrase, which is the NCP phrase. In NCP phrase is performing the normal NCP parameters. Okay. Now there are two ways for you to configure the MP concept, or in this case the configuration. So in the VRP, we can use a virtual template VT, or we can just use the MP group mode. All right. So in your exam, both of these mode you need to know how to configure. Let's look into the PPPoE principle. PPP is a point-to-point protocol. OE stands for over Ethernet. All right. So first we are going to look into the overview, and then we look into the process on how PPPoE session established. Now first, why that the PPPoE is required. Okay, so now if you look into the high overview here, PPPoE enable multiple hosts on an Ethernet to connect to a remote access device. In this case, I have multiple clients. As you can see, I have client 1, 2, and 3 connected to a PPPoE. From here, we normally connect to the internet. And PPPoE is used in a client-server networking model. Now, for those of you who are viewing this video, most likely right now you may be using the fiber, or traditionally we are using DSL. So if you are using DSL, then you are using a PPPoE. Now, in our PPP, we can do authentication. Now, this is the features that is required by PPPoE, as well as the accounting. All right, that is where the provider will bill you according to your bandwidth. Now, but here, this is our Ethernet. Now, how can we allow the Ethernet, because this is a multi-access network, to connect to a single PPPoE? So we borrow the concept of PPP together, that is running over Ethernet. So we have the PPPoE. Now let's look into the mechanism on how PPPoE work. Now this is a client-server type of architecture. So we have a client. This client, basically we need to run a PPPoE software. All right, even your XP, your Windows 7 or Windows 8, or even Windows 10, all of these, including the Linux, have this client or PPPoE client. So no issue. Most of the modern operating systems do have the PPPoE. Now in this PPPoE, we need to configure our username and the password. All right, with the username and password, this is being sent to the PPPoE for authentication. Now exactly how this process works. Now we have three phrases here. First is the discovery. All right, that's the first process. So once the discovery process is done, then it go into the session, and if let's say you want to terminate it, all right, so we have a termination process. Now let's look into the first process here. The first process is called broadcast PADI. This is a PPP, active discovery initialization. So when you make a PPP connection, it will send this to the server, but you do not know where is the server, so you are going to discover. All right, so this is where the discovery is. You are going to discover the server using the MAC address. So remember, that is where the Ethernet come in. Okay, now when the server receive the discovery, all right, so it's going to send an offer to the client. All right, now this time we are going to use the MAC address to able to communicate. Now once the client receives the offer, the client is going to send a request to the server stating that I'm actually request to the OE session. Okay, now if the parameters is correct, then the PPPoE server is going to send out the session to the client. All right, so this is where we have the PADI, PEDO, PEDDER, and PASS. All right, so this is where the session established. It go into the second phrase. The second phrase will be on our session. Now in our session, the session ID will be created, all right, to identify that this is a client, that this unique ID identify this session ID, and data is being transmission. Now during here, this process of a session, a regular PPP taking place, including your authentication. Alright, the LCP as well as the NCP is happening here, which means that this is where the user also getting the IP address. Now, assuming that the user disconnect, then the server is going to disconnect it gracefully and send a termination signal. Now, let's have a look into our Wireshark trace. Now, what you can see from here, I have a trace between a client and the server. Now, firstly, we have the PPPoE, alright? So this is a PPPoE, Active Discovery Initialization. Now, in the Active Discovery Initialization, the client do not know where is the server. Alright, so you can see that this is Ethernet, and inside here we have the PPP. So it's PPP over Ethernet. So that is our PPPoE. As you can see from here, you can see the destination is a broadcast. Alright, because the client have no idea where is the PPPoE server. Alright, so this is the initialization. Now on the second frame, as you can see that this is where the server discovered that the client sent out the initialization. Now this is where the server respond back to the client. As you can see that when the server respond back to the client, you can see that they are actually having the MAC address identified. Alright, because when you do a discovery, the server already know where you are. So this is the offer from the server. Now upon receive, alright, upon receive it, so the client is going to send a request. This is a request requesting for the AC. Alright, this is where the server AC name is. They're trying to match. Alright, this is AC means that this attachment concentrator. That is the name. Alright, this is a unique name because you may have multiple PPPoE server connected to the same segment. So only the segment where have the name, alright, that's selected to respond back to you. Now, assuming that the server do receive the request and accept it, then it's going to send out the confirmation, the session confirmation, which is PADS. Alright. So these are the 4 frame on the discovery. Now, once this is being done, now the next one here, that's the kick in here, is a PPP. This is a regular PPP. Now, from the earlier slide that I mentioned to you, so this is a PPP LCP negotiation. There's a request, okay, and there's an acknowledgement. Okay, that is your MRU and the magic number. And at the same time, they also request for a dynamic IP as well as authentication. So you can see that from here, the LCP, they do have the PEP. Alright, they request for the PEP authentication. Okay, so that is your negative neg is because that they are actually looking for parameters that is unacceptable. They request again and finally is accepted. And this is where the PPP PEP is being requested. Okay, so you can see that this is our authentication using the PEP. And because the PEP is using clear password, so as you can see from here, my password is R1. And finally, it get is this is acknowledgement. So once it's being done, the IPCP is configure, all right, which give you the IP address. This is the IP control protocol. So there's a request and acknowledgement, all right, for the IP address. Now, assuming that the client terminate, then we have this active discovery termination. Okay, so from here, you can see that the entire process of PPPoE.
Thanks for watching. Please do not forget to subscribe to our channel.